Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zakwan. This project focuses on detecting vehicle number plate using smartphone camera input and AI detection. The system is designed as a support tool for police roadblock checking, where an officer could use a phone or camera to automatically detect a vehicle plate in real time. The system works in stages. First, a video feed is captured, either from a phone camera or a raw video. Each frame is sent to a Roboflow-trained detection model, which returns a bounding box around any plate it finds, along with a confidence score. The next planned test is OCR to read the actual plate number, followed by displaying a result for the officer to check. The dataset was labeled using one class called plate. The bounding box was drawn around the visible number plate area only, not the whole vehicle. In total, the dataset contains 988 images, split as 78% for training and 11% for validation and 11% for testing. Following standard practice to avoid the model being evaluated on data it has already seen. After training, the model achieved around 87 to 90% MAP at the standard of 0.5 IOU threshold, which show it can detect plate quite reliably. However, the MAP at the stricter 50 to 95 range is lower, meaning the bounding blocks are usually in the right area but their exit edge could still be tighter. This is a normal trade-off for a single class detector trained on a dataset of this size. Here is a static image test first. Since this batch show the model raw detection ability before any real-time complication, you can see the bounding box correctly locate the plate, which a confidence score display above it. For video, I tested using a webcam and a phone camera feed calling the Roboflow API for each frame because each detection requires a round trip to Roboflow cloud server. There is inherent network latency on every frame. This is not something that can be fully removed when using a cloud host model. To keep the video itself smooth, I separated the camera display from the detection process. The video plays normally while detection happens in the background and update the bounding box whenever a result returns. The trade-off is that during fast vehicle movement, the bounding box can visibly lag slightly behind the plate real position. Since it's reporting where the plate was a moment ago, not where it is right now, I also found that smaller, lower quality images sent to the API reduce this delay noticeably, which is the kind of practical engineering trade-off this project requires, balancing detection accuracy against real-time responsiveness. Reading the actual plate number from the detected region was planned as the next stage of this system, but was not implemented in this version due to time constraint. The detection model reliably find where the plate is. Reading the character themselves would require an additional OCR step, such as Google ML Kit or Roboflow on OCR model applied to the crop plate region. I chose to focus my available time on getting plate detection working reliably first, since that's the foundation the OCR step would depend on. This is listed below as planned future work rather than a completed feature. There are several non-limitations. Fast-moving vehicle cause motion blur, which reduce detection reliability. Plates appear very small when the vehicle is far from the camera, making them harder to detect. Cloud-based detection introduces real network latency, which causes the display bounding box to lag slightly behind a moving vehicle. Phone camera quality also affect how reliable a plate would be for OCR. For future improvement, this could be addressed with higher frame rate camera, a larger and more varied training dataset, integrating an OCR model, frame-to-frame tracking to smooth the visual lag between detection, and eventually packaging this into a complete mobile application rather than a test script. Thank you for watching. This project demonstrates a working plate detection pipeline using Roboflow, which clear, honestly documented limitation and a defined path for future improvement. Thank you.